So beautiful places inspire us. For centuries, humans have been expressing their appreciation for beauty in their literature, their philosophy, and their art. Often, as individuals, we seek beautiful places, perhaps to lift our spirits or to feel more relaxed. And it turns out there's actually evidence confirming that there should be a connection between beautiful places and why we actually seek them out. So, as Herb mentioned before, I was doing my PhD at the University of Warwick and the Alan Turing Institute, and I was looking at the connection between beautiful places and our well-being. And I was able to publish several papers on this, so I created the first large-scale evidence that showed that across all of England, individuals report better health when they live in more beautiful areas. And individuals are significantly happier when they visit more beautiful areas. And this also holds after controlling for factors such as green space as well as income deprivation. So there really is something there. But this talk is basically on how we measure beautiful places, because you must be wondering, like, how on earth are we actually measuring beauty? So you can imagine that one way to measure it is maybe to ask people, what is beautiful in your neighborhood? Or what do you just find beautiful in your everyday life? But the problem is, if you want to conduct this survey in an entire country, it's going to be time-consuming and very costly. So it's just not feasible, and that's why we haven't had large-scale studies until recently. But luckily these days, we spend a lot of time on the internet. So the internet is actually a great source of data. So I was really excited when I came across this website called Scenic or Not. And it's just a simple online game people play, and they rate these images between 1 and 10. But what's happening in the background is each image represents a square kilometer of Great Britain. So when you map these out, you see a lot of the scenic spots are coming out. It's like places we like to go hiking come out as being scenic. So it's actually that one image is giving a very good signal of beauty around the country. And I have about 217,000 images, rated about 1.5 million times. So this is a lot of data. This is really great. So now, how can I actually analyze all this data? So this is when neural networks come to the rescue, because they're really great at image detection. So just to get everybody on the same page, I'm going to do a little bit of a introduction into what neural networks are. Let's take a case where we want to figure out how we're going to distinguish between zeros and sixes, and we want to write a computer algorithm to determine that. And one way we could do that is just to create rules. So, we'll say the curve should be a little bit higher, and then that's a 6. But after a while, you'll end up coming up with a lot of rules just for the 0 and 6. And you haven't really figured out all the rules to tell between a 1 and a 7. So rules-based algorithms can be quite clunky when it comes to things that are quite complex. Another way we can think about it is we can actually have algorithms learn by themselves. And this is where the term machine learning comes from. And we basically can train an algorithm just like you tell a child, here's a cat, here's a dog, here's a cat, here's a dog, and eventually okay, I got it, that's a cat. And that's as simple the way machine learning algorithms work. We just give them data, and they learn from the data. And one of these really amazing machine learning algorithms is deep neural networks. So they're inspired by how we think the neurons in our brain work. And these are amazing when it comes to images. So they basically learn how to see patterns. So when they're trying to distinguish the difference between different numbers, they're just going to be looking at lines and loops and creating their own pattern recognition rules themselves to try to distinguish between numbers. And we could do that with faces as well. They'll look, break down the faces into different characteristics and learn the patterns and eventually be able to do facial recognition. So these deep neural networks are driving a lot of what we've seen happen with image recognition and why we might end up having self-driving cars one day. So I took one of these deep neural networks that's very good at understanding scenes from pictures. And I gave that algorithm, my 212,000 images, and I asked the algorithm, what is it seeing that people are actually rating as being beautiful? And this algorithm can extract lots of different characteristics. So we've got two different pictures here. It can say, I think there's a skyscraper in here. I think there's an ocean in this one. So, and you can, so this is a man-made, this is natural. So it's really good at extracting tons of information from these images. And this is how the analysis would look. So you can see, this is an example of valley, grass, and no horizon. So it can tell you with a certain probability, I think there's valley in here. I think that this scene is mainly grass. Or can I see out to the horizon or not? So now I then fed it all the images, did a statistical analysis, and what did the algorithm tell me? So turns out that, unsurprisingly, of course, there are a lot of natural features that people pick out as being beautiful. So it could be coast, valley, mountains, forests, and trees. But surprisingly, we also see cottage, lighthouse, and viaducts, like bridge-like structures. So I was really fascinated by the fact that we were starting to see built-up structures as being considered beautiful as well. And I think you'll all agree, when you're walking through this beautiful town, there's so many beautiful buildings. So beauty is not just natural beauty, buildings can also be beautiful as well. What do we find as being not so beautiful? Not surprising. Of course, industrial and highway, or just kind of these kind of settings, people downrate. Really interesting, though, is it came out that no horizon is also a not beautiful feature. And you can imagine this, that when you kind of go out into beautiful scenery, what actually also makes it beautiful is the fact that you can see out into the horizon, you can see out to the distance. So that might be something to do with this well-being connection that we're seeing. And really surprisingly, I thought this was, quite unexpected, is that grass is a feature that is not rated as not beautiful. And this is flat grass. So, and I think this is really interesting for the green space debate, because in policy, there's a lot of, basically rules that say, let's introduce green space, but nobody really talks about the quality of that green space. And if that green space doesn't have trees or valley contours, people are not going to consider it beautiful. So it brings up the conversation of, if we're going to create green space for people, let's inject other features to actually make it a beautiful place that people want to use. So, I mentioned before that scenic or not gives me an image for every square kilometer of England. Now, what about the city? If we take one image for a city, that's not going to be good enough, because in a city, you've got a wide variety of scenery. So we need a more dense, we need to create ratings that are valid for high-density areas as well. So there's a problem with neural networks. And this is why it used to be that a lot of big companies could only use neural networks. It's because you actually need millions and millions and millions of samples. So it used to not be that accessible for an everyday person to go and train these algorithms, because how am I going to get data on that scale? But there is a really clever technique that we can use, and it is called transfer learning. So what we can do is we can take a deep neural network that already knows how to do something. So I mentioned earlier that I took a deep neural network that can already detect what's in the scene. So that's the same algorithm I was using to figure out what features were beautiful and not beautiful. And I could train this deep neural network to do something else. So what you're doing is you only have to feed it, say, a few 100,000 images, better than the millions. And this neural network can start to learn how to do a slightly different task. So I could teach this task that can already recognize scenes now to recognize beauty. And, well, it worked. So I live in London, and I just wanted to see, okay, so it's looking good with the numbers, but, is it intuitive? So I took all the images from a website called Geograph. So Geograph is a website where people submit documentary photos of their areas. So it's a really great coverage of all over England. And I wanted to see, am I going to find the beautiful places I know in London in my data? So I live in Muswell Hill, like another speaker as well, coincidentally. And I remember lockdown, I was so happy to be living where it was still a 30-minute walk to Hampstead Heath, but very happy to have access to this beautiful park. And turns out that my algorithm also agrees it's a beautiful park. So the way we can read this graph is if we look at the purple dots, that's really scenic, green is scenic, and gray is not scenic. So all around Hampstead Heath, we see these dots appearing as scenic. So these are images that the algorithm has analyzed and then said, hey, this is beautiful. So, for example, that's a beautiful image of Hampstead Heath. We can also then look at central London and see what's happening there. And we see there's some clusters of dots. And really interestingly, if you look, there's like a path that's going through. And I'm like, oh, that's really interesting. Is there like this beautiful road that I don't really know about? Like, what's going on? And turns out that's Regent's Canal. So it picks up the parks around London as being beautiful. But this algorithm also recognized that the canal is also something people find beautiful. And it picked out, by looking at the images, here's something that can be really beautiful. And it knows that things are not, it's like the whole, what I mentioned before, that just because it's green doesn't necessarily mean it's beautiful. So it does pick up on flat areas of grass, green spaces next to highways, or green spaces not really well taken care of. So it's really smart. This one algorithm is learning all this. And finally, there's another beautiful area in London, Tower Hill, reminiscent of some of the beautiful buildings here. And it also recognized that this beautiful building is also, this building is beautiful. So I was absolutely fascinated by this deep neural network that is one algorithm that can understand beauty in so many ways. So it turns out that beauty is not in the eye of the human beholder. A computer can also be taught to understand beauty as well. And I think this is absolutely fascinating because judging beauty is taught to be something that's quite complex and only humans can do, but turns out AI can also do that. But what does this really mean? Why is this actually so exciting? So I think that algorithms like this can actually help us design the future cities that we actually want to live in. And right now, the way we design cities, or the way we design places, is based on the decision of only a few people. So it could be the planning officers, it might be the architects, it could be the developers, it might be the mayor of the city. But in the end of the day, the decisions are only made by a few people, and these decisions impact millions of people's lives. And sometimes these decisions go wrong. So we have, tons of social housing buildings that have popped up around the country, and this was thought to be a very great idea by some few people, but the people that live in these buildings, they don't really appreciate it. They actually really suffer because of this architecture. So what I think algorithms like this can actually enable is a future where we make decisions that benefit more people. So if we think about it, the scenic or not data, that is crowdsourcing the opinions of thousands of people. So we can crowdsource the opinions of thousands and thousands of people around the country, feed that data into an algorithm, and then we can create a more democratized view of what beauty actually means. So we don't need to count on the kind of the goodness of a few people. We can actually ask everybody that actually has to live in these places, what do they actually want, and use AI to collate that data into decisions that are actually beneficial. And this is why I love working in AI, because it enables a lot of great things for the world. So, thank you.
Thank you, Doctor. I guess one of the things so you brought up the example of one of the, like a public, an ugly public building, right? Now, my understanding, I'm hardly expert in those sorts of stuff, but oftentimes, sometimes those buildings come out ugly because, for example, let's say Durham County Council was wanting to build a new office for itself, right? That oftentimes, sorry, maybe it's a bad example. Sorry, they did that. It's a whole long story. We'll get into it. But that they don't want it to be too beautiful, because they're like, oh, well, they're spending all this money on themselves. Right? So I'm just wondering, if at some theoretical point in the future, you could, the data we've been so good, you say it's going to be beautiful, but it's going to evoke a sense of responsible spending, or do you know what I mean?
Yeah, I think it's a good point. I think people think that spending money on beauty is frivolous. And the thing is, I'm seeing with my PhD research that beauty does matter. It does make you feel better.
Yeah.
So it's not a frivolous thing to spend money on, that it is important. But
Sure.
maybe we just have to be creative to find ways to build things that are beautiful that isn't going to cost an arm and a leg. But it is important.
I guess what I'm saying
Yeah.
is just because, I mean, so
Yeah.
just accepting, like, I think we talked about this a
Yeah.
little before, is
Yeah.
that oftentimes you'll have, let's say, for example, you lived in an area where the population was just distinctly different from the average. Let's say it was a lot older or a lot younger, or maybe something where, you want to design a building that is considered to be sort of avant-garde or cutting edge,
Yeah, that's a
right?
good point, yeah.
And so I'm just wondering, like, could you have effectively subsets of data that would allow you to effectively program for that?
No, that's a good idea. So one of the things I don't like to do is I didn't talk about architectural styles, because I don't think it's about style. It's about characteristics that just kind of maybe contribute to human well-being. So for example, looking out to the horizon or having an open space, I think there are rules that could be translated that go beyond style or beyond, is it contemporary or historical? I don't think those matter. We have to break it down to the architectural principles that are beneficial and not worry too much about, is this style good or is this style is not bad. So it is about thinking about beauty in a bit of a different way.
Okay, so just last question. How long before, like, we'd have enough, I guess, ultimately sufficient data, and then I guess the one is around data, but then I guess the other thing is around actually getting people to pay attention to using these sorts of tools. I mean, so how long do you think before you start to see, people in some capacity starting to actively use AI tools to thereby design spaces or buildings?
I think it's still going to be a while. AI, some people aren't doing good with AI and actually are kind of creating a bad reputation for AI, unfortunately. But these things AI can be used in a good way if you think about it really carefully. And I also think it's important to have human in the loop. So if we think about AI tools enabling people to make decisions, and we're not just saying the AI algorithm makes decisions, then I think we're going to get there faster. Because we're just talking about the AI enabling us to, so for example, crowdsource opinions. Human can still be in the loop, just double checking, nothing's gone, really crazy. And then, that interaction itself can maybe help people become more comfortable with that type of innovation.
Doctor, thank you so much. Cheers.
Thank you.
Cheers. Oh, I need you. Thank you.